In this video, we're going to extend and finish implementing the customization options for our skill tree. For example, we'll be able to control the scale of the various elements of the UI, like the icons, change the color of the individual parts, like the text, and change the shear and opacity of the various parts as well. This will allow for many new emergent animation possibilities when switching between the states, like here where you see the text of the nodes animating in an interesting way, simply by having different opacity and shear values for the text between the learnable and unlearnable states. So we currently have this skill tree with a fairly high degree of customization. In fact, as we know, all of the nodes that we see on the screen are made up of the same material with different parameter settings. So there's already a fairly high degree of customization. In this video, we're going to finish off the node customization. In particular, we're going to add color and opacity, translation, scale, and shear settings to the icon in the center, the text, and the node all together. So similar to the last video, we are going to add design options to the node appearance category in the component, which will let us artistically design our node states. And then we will use an interface to call on that information from the skill tree node. And then in construct and also the update, we will set those appearance parameters. So that's what we're going to do today. So we'll start by creating a struct that we'll use to transfer that data from the component to the node. So in our MISC data folder, right click, go to Blueprint, Structure, and we'll call it S_node appearance. Open it up. Most of the data will be vector 2Ds, so we'll make this a vector 2D and then duplicate it. And we're gonna add variables, making sure there are 14 total. And we're going to name them. And we'll change a few of the variable types on the right. The color and opacity is a linear color. And the icon and text color and opacities are also linear colors. And the icon angle and text angle are both floats. Now we'll come over here to the default values tab, click on the color at the top, and we're going to change these values to something very specific, 0.999, 0.999, 0.999, and 1. We'll see why we're doing this a little bit later. For now, drag the new value up to your color bar, click OK, and you're going to set the other two to the same values that we've just saved out. And the only other defaults we're going to change is all three scales to 1 and 1. Now we're done creating our struct. We can save and close that. And we're going to send that struct info from our component to our node, and we can send it over with the other appearance info. So we'll open up our iSkillTreePC component interface, and in the get node appearance info, we'll add another output. We'll call it node appearance info, and we'll set it to that struct that we just created. And we can save and close the interface. And we're going to have those settings in the component so that we can design them. So in the components folder, open up the component, and we'll expand the skill tree under variables and the node appearance. And we're going to add that struct variable for each state, similar to how we had this material instance for each state earlier. So we'll add a variable, and let's call this first one base. We'll move it to the node appearance category, change its type to the new struct that we just created. And I'm going to reorder these. I'm going to drag the state transition duration to the top, and then I'm going to add these just underneath that. And this will determine the order that they show in the child component when we're designing. I'm going to duplicate this variable 7 times, so there are 8 total. And we'll rename them to the different state names. And the last one, the 8th one, we're going to call general node appearance. And we'll see why we're doing that shortly. We're going to put general node appearance first, and then the rest under base. And we can compile and save. And now under the interfaces, under the internal, we're going to open up get node appearance info. And we're going to output this new appearance info that we just created. So we can promote this to a local variable. Compile. So now the reason that we created a general node appearance here is so that when we want to make a change to all of the nodes in the skill tree, we can just change this. We don't have to go in and change every single time we make a change it 7 times. This is a time saver for the designer, or for us if we are designing. So what we're going to do is output the general node appearance and then additively apply whichever state we're getting in this function. We're going to create a function to do that after each one of these. So we'll create a function, call it calculate node appearance. It's going to have an input and an output of that new struct that we just created. The input we can call node tweaks, and the output we can call final appearance. Let's split the struct pin of both. So we're going to get the general node appearance, we can split that, and we're going to additively apply the tweaks on top of the general. In order to do that, some of these need to be multiplied and some of these need to be added. The scales need to be multiplied, the translation and shear need to be added, and the color opacity we're going to do something a little bit different with. So this general node appearance scale will multiply by the node tweaks scale and put it into the final appearance scale. We can copy and paste this twice and do the same for the other 2 scales, making sure that they go to their corresponding scales. General node appearance icon scale, node tweaks icon scale, final appearance icon scale. General node appearance text scale, node tweaks text scale, final appearance text scale. And we're going to add the translations and shears. And remember, we're doing this, it's a little bit more work now, but it's going to save a lot of tediosity during the design process and the iteration, so it's well worth it. So we've additively done the translation and shears now. Now we're going to additively do the angles. We can do that with addition as well. Don't forget to connect the execute. And for the color, we're going to do something a little bit different. For the color, we're going to create another function, call it determine color, and we're going to add an input called tweak color. It's going to be a linear color structure. And we're going to add 1 more input and 1 output. The other input's going to be called general color, and the output's going to be called color. Make it a pure function. And if the tweak color is not equal to that very specific value that we created earlier, which is the default for our colors in our struct, then we'll return the tweak color. And if it is equal to that very specific thing, then we'll return the general color. And basically what this is doing is it's making it so anytime a color is tweaked by the designer, it gets overridden to that tweak. Because the designer's going to be playing with sliders, moving them around. That's why we don't set this to 1, because it could accidentally be set and then you could get the wrong result. So we'll go back to the calculate node appearance function. We'll drag in that determine color, and we're going to drag the tweak into the tweak, and the general node appearance into the general, and then the color into the final. And we're going to do that for each of the others as well. So we'll duplicate this twice. And we're finished with this function. It is a bit chaotic, and there is a chance that some of the wires were put into the wrong places. Later on in this video, we'll test and make sure that things are working correctly. And again, this is going to save us a lot of time in the long run. So now we can go back to the get node appearance function. We can drag in that new calculate node appearance function, and we can drag in the base and that appearance info local variable that we're outputting. We can just set the final appearance to that. And we're going to do this same thing 7 times, inputting the correct settings each time. So we'll duplicate this 6 times, having 7 total. And we'll replace this base with the correct state from each output. So now we're all done with our work in the component. When the component's called, it will output the correct appearance settings to the node. So now in our widgets, we can open up the skill tree node widget, and in the construct, we'll scroll over to this assign static material and appearance info. And this node appearance info output, we can right click promote to variable, and we'll call this previous node appearance info. We can move this to the node state and duplicate it and call the other one updated node appearance info, because we're going to be lerping between the two. Disconnect this. We're going to set the previous and the updated. The updated is going to be set from this node appearance info output, and the previous is going to be set from the updated. So basically what this is saying is it's remembering what it currently is and setting it to something called previous, and then it's updating. And just like we did an update material appearance params here, we're going to create a new function, non-material appearance params. Drag it into the node appearance change. And we're going to have a float input called update progress. Make it a float. Let's go back and add that function right after the update material appearance params. And we can set it to 1, just like this. Let's go into the function. And in here, we're going to set the new appearance. So we'll make a sequence, add a pin, and we're going to drag in the previous node appearance info and the updated node appearance info, splitting each. And we're going to lerp from the previous to the updated using this function input, the update progress. And then we can just set the color and opacity of the user widget to that. And now we're going to copy these two, paste them over here, and we're also going to lerp the translation, scale, and shear. We can't drag off the translation and do a lerp, but what we can do is type in lerp vector, drag off the translation, input it into that, convert the 2D to a 3D, and do the same thing for B. And we can select these, collapse to function, and we can call it lerp vector 2D. Drag it into the node appearance change category, make it a pure function, open it up, and we can also output that vector 2D. And we'll call the inputs A and B and add one more input, call it alpha, make it a float. Connect these, connect the alpha to the alpha, leave these at 0, and we're all done with this helper function. We can compile and close it. So now we're lerping the translation to this output progress, and we're going to set render transform of the widget. Right click, split. This is the translation, and now in the same way we can do the scale and shear. So we'll duplicate this twice. Now we can comment this. This is the overall appearance. We can select everything and duplicate the entire thing twice. Connect to the reroutes. The second section is going to be icon appearance, and the last section is going to be text appearance. So for the icon appearance section, the references will be the icon. We can't just drag it in here. So we have to drag off the icon, set color and opacity, and input this. We can drag the icon into here because this is calling the same base function. The only other thing we need to do here, unlike the section above, is input the transform angle of the icon. And we'll also do that by lerping the float. And we're going to do the same thing with the text down here. We can't drag in the text into here, so we'll drag it here, set color and opacity, and we can't input this directly into here, but we can right click, split, and input it into here. Keep it at specific color. I'm just control left clicking here, delete the old one, and drag the text into here, and we'll lerp the text angle. And we also need to add the update progress here, and we forgot to do it up here. And there's another small mistake we made. We set all of the appearances to the top two from here. We need to set the icon appearance to the icon appearances, and the icon translation scale and shear to the icon translation scale and shears. And we need to do the same for the text. Now back in our event graph, in the event construct, over here where we're working, we're going to select both of these, and because we're going to do this more than one time, we'll collapse this to a function, and we'll just call it update node appearance. We'll drag it into the node appearance change category, and we're going to add an input called node update progress and an output called node update progress out. Set it to 1. Remember to set it to 1 or it will not work here. Open it up, connect the return, and we're just going to set the node update progress into all 3. We no longer need the update progress out in the update material appearance params here. We can delete it if we want, because now we're outputting it in the overriding function. We'll notice that when we delete it and compile, we're brought to this error here, which is in the update node state. And that's because we were using this function before, which we need to now replace with the update node appearance function that contains this function and our new functionality. So we can delete the old one, input the update progress into here, and output the update progress here. Now, one more thing we need to do is in the nodes event graph, in the update node state, click on prepare to update node, go into catch updated node appearance, and we need to also catch this new non-material appearance info in here that we've created. So we're going to output that from here, from this interface call. So in the MISC data, we'll open up the iSkillTree PC component, get updating node appearance info. We can add that output here. We can call it updated non-material appearance info and make it that new structure that we created, S node appearance. Compile, save. Now we see it here, and we're going to set it to that updated node appearance info variable that we created. And before all of this, we also need to set the previous node appearance info to what was formerly the updated. And one more thing we need to do is open up the component and go into the get updating node appearance info interface function here. We need to output something into this updated non-material appearance info. So we'll right click, promote to local variable. And just like with the other function, we're going to use our calculate node appearance function, inputting the appropriate state into the node tweaks. So the first one will be base, and setting the output to that local variable that we just created. And we can duplicate this for each one. And we can replace the base with the appropriate state by dragging it over the base. And now we're all finished. Now if we go into our example folder and open up our child component, which is the one we're using for all the designs, we can see that the node appearance category now has all these additional fields that we can use for artistic tweaks. So now just to quickly see some of the way the functionality works, we can expand the learnable and the learnable selected tabs, and we can change the color and opacity of both to something very obvious. Now when we fire up the game, we'll see that the learnable is the blue that we set it to, overriding everything. And once we select it, it becomes red, overriding everything. So the functionality works. And you'll see what I did here is make it so when you select a node, it changes the text color from black to white, and it changes the translation a little bit. And then when you learn it, it blends over to a brown. And the way I did that is I set the learned and learned selected to this brown color, and the learnable selected, I selected it and dragged it all the way up to white. The other ones look right, but remember they're at 0.999. And for the unlearnable, I set the text color and opacity to invisible. And that makes it so on the unlearnable nodes here, you can't see the text. But then as soon as they become learnable, the text kind of blends in, and you'll see it skews in too. It doesn't just appear, and it just kind of twists inward And the way I did that is by making the text shear in the unlearnable to 45. So you can do all sorts of cool like animation transitions between node states, and there's really a lot of flexibility here and power to play around with and get it looking and feeling exactly the way you want it in any way, shape, or form. You know, you can translate, move the text around in different states. You can have different elements of the node, you know, fading in and out or changing scale and size as they transform to different states. Really just anything that you can come up with that looks and feels good to you. You have full artistic control in here. I also made it so in the general node appearance, I changed the icon scale to 0.8, and that makes them just slightly smaller. I felt like they were kind of crowding the borders. I also set the text color and opacity to black by default. So you can see that here. They just fit, the icons fit a little bit nicer inside the node, and all of the text is black by default, and then it becomes white when you select it. So there's one last artistic touch that's missing from this tech tree, and that's the ability to change the text font and the text wrapping. So let's add that in as a last touch real quickly here. We'll open up the component, and we'll add a new variable. We'll call it node text, and we'll make it a slate font info struct. And we'll add that to the category skill tree, vertical bar, text appearance. We can see it here. We'll add one more variable. We'll call it text wrapping. We'll make that a float, add that to the text appearance. And we're gonna go to the MISC data, open up the iSkillTree component, get node info. We're gonna add those outputs. So add two. One's called font, the other's called text wrapping. Font is a slate font info. Text wrapping's a float. Compile, close. And now in the interfaces internal, we'll go to the get node info. Now we can add those variables into the outputs. Before we close this, we want to make sure the text wrapping is set to something. 200 is a pretty good number, and the node text is fine as is. Now we can go into the widgets folder, open up the skill tree node, and in the construct here, we're calling that function get node info, so we can set the font and the text wrapping here. So in the references, we'll drag in the text, set font, and set it to that output. Drag off the text, and we'll set wrap text at to that output. And we can comment this. And now if we open back up our child component, we have the text appearance category. We can expand the node text, set it to a font type that we imported, for example, Augusta 40. Change a couple parameters. Now we fire up the game. We can see the text is now updated, and it looks much better. So now that we're done implementing all the controls to control the visuals of the system, in the next video we'll add sound.